Hi, welcome to my video, part 5 of solving more inequalities, and this is number 2. And number 2 has inequalities which are made up of two variables. So the only way you can solve these is by graphing, not by algebra. Notice we have negative 2y plus x minus 2 is greater than 0. This is a degree of 1, this is a degree of 1, so this is a linear. So it's a linear, we will write it as y equals mx plus b, which is a line. So we'll solve for y. So we'll move the x to the right, make it negative, 2 to the right, negative 2 to the right, and make it positive. We'll divide by negative 2. And so the y, because we divide by negative, that changes to a less than. Negative divided by negative is 1 over positive 1/2, and we get a negative 1. So this is y equals mx plus b. So the slope is 1/2, and the y-intercept is negative 1. So we plot the y-intercept is negative 1 right here, and we slope is rise over run, so it's a 1 over 2. So we'll rise 1 and run 2. We'll rise 1 again and run 2. So notice this is a positive slope. And go back to the inequality is this is less than equal to, so the boundary line is not solid. The boundary line is not included. So this is the line. So this is the line y equals a half x minus 1, and the boundary line is not included. So we have to shade, and in relation to the line, less than is below, but to test that, let's use a test point. And the test point I like to use, if I can, is 0, 0, because it's the easiest to plug in. So y is less than a half x minus 1 is the inequality worked out. Or we probably should go back to the original, because there could be an error. Let's go back to the original. So let's put y is 0 and x is 0 in this inequality. So that's a 0 plus 0 minus 2 is greater than 0. So negative 2 is greater than 0. That's a no. So this point, we do not shade on this side, we shade down here. So if we plugged it into the one that we solved for, y is 0, half times 0 minus 1, 0 is less than, 0 minus 1, 0 is less than negative 1. So either we did the original or the one we solved, it's a no. But this one is true if you solved it correctly. So going back into the original might be the better way. And again, it's a no, so this point 0, 0 is not, so we shade below. And again, y is less than on a linear is below the line, not up. Okay, let's have a look at another inequality to solve by graphing. And this one we have y minus 3 over x is greater than or equal to x subtract 4. Notice that x is in the denominator, so x cannot be 0. It's the first thing, because we're dividing by 0. Now, the LCD, we have a fraction. The LCD is only one denominator and is x, so the LCD is x. So we'll multiply each part of the equation by x. And when we do that, the denominators will cancel. I get a y minus 3 greater than or equal to x times x, x squared, negative 4 times x, negative 4x. And we'll notice now that this is an x squared, a quadratic, so I'll move the minus 3 to the right side and make it positive. I have a quadratic, so this is y equals a x squared plus bx plus c. So that's a parabola, quadratic parabola, and so that means that a is 1, b is negative 4, and c is 3. Since we know that this is a parabola, y equals ax squared plus bx plus c. If you make this an equal sign, this is the boundary line, or the boundary. We say line, the boundary, because the parabola is made of a curve, not of one line. So, to get the vertex of a parabola, what we do is we do x equals negative b over 2a. So b is negative 4, a is 1, so that's 4 over 2. So the x-coordinate of vertex is negative 2. So we plug that in to y equals x squared minus 4x plus 3. And we plug in 2 for x. So we get a 4 minus 8 plus 3. So that's 7 minus 8 is negative 1. So the vertex is 2, negative 1. So if we plot that vertex, vertex is x is 2, negative 1. There it is right there. And also, in relation to this parabola, we can let x, we can get, say the x-intercepts. Okay, let's get the x-intercepts. We can get the x-intercepts by letting y equal 0. So we let 0 equals x squared minus 4x plus 3. And this is factorable. Let's see, x squared is x and x. Factors of 3 are 3 and 1. The product is positive, sum is negative, so it's a negative 3, negative 1. So x minus 3 is equal to 0. X minus 1 is equal to 0. X is equal to 3, or x is equal to 1. So that's the ordered pairs, 3, 0, and 1, 0. So those ordered pairs are 3, 0, right there, and right here. 1, 0, 1, 0, and 3, 0. And we also can find a y-intercept. We find a y-intercept when we let x equal 0. So y equals x squared minus 4x plus 3. And when we let x equal 0, sub it in. And as you can see very quickly, these are zeros, so we get a 3. So 0 minus 0 plus 3, we get a 3. So that's the ordered pair when x is 0, y is 3. So when x is 0, y is 3 right here. So that's the parabola. And notice the parabola, this is positive, so it's opening upward from the vertex. And the boundary line is an equal sign there. So an equal sign, greater than equal to. So the equal sign means the boundary is solid, shaded in. And the greater than, let's get the boundary solid. So the boundary line, there's the parabola going up through. Boundary line is solid. And now we got to look at the greater than. So the greater than, normally in relation to this graph, greater than is up. But let's check. Let's do a test point. A test point. So the test point I normally do is 0, 0. But notice we can't use 0 in here because this point at 0, 0, 3, we can't have x 0. So this point 0, 3 it's an intercept, but it's not included in my graph. It passes through this, but it's not included in my graph. So another test point I will use is this one right here, which is 2, 0. So we check. We have y minus 3 over x greater than or equal to x minus 4 is the original. So y is 0 and x is 2. So we put 0 in for y. X is 2. That's a negative 3 over 2 greater than or equal to negative 2. Negative 1.5 is greater than or equal to negative 2. Negative 1.5 is here. Negative 2 is here. So that's to the right. So that's a yes. So that means that this point is in the graph. So that means I'm shading inside the parabola or going up. And you got to be, so you see going up, as this goes up and up and up, like this, keeps on going, we keep on shading. So as long as this goes to infinity for the y, infinity, all points that fit inside of this parabola in here satisfy this inequality. And another one, just a different one. Again, look at this. We have x squared plus y squared plus 6x minus 4y is less than 3. Notice we have an x squared y squared, so it's a quadratic. And we have an x squared plus y squared, so that's the circle. So we group the x's to find the center. We group the y's, again, to find the center. So a half of 6 is 3, 3 squared is 9. That could make it a perfect square trinomial. A half of negative 4 is negative 2 squared is 4. So we put a 9 on this side, so we put a 9 on this side to balance it. We put 4 here to complete the square, so we'll put a 4 on the right side. And because we complete the square, this is an x squared is an x. A half of plus 6 is a plus 3. So the factorization of this trinomial is x plus 3 times x plus 3, which is x plus 3 squared. And this trinomial right here, perfect square trinomial, is a y, and a half of negative 4 is a negative 2. And again, the factorization of this trinomial, which is the perfect square, is made up of y minus 2 squared, which is y minus 2 times y minus 2 if you factor it. And this adds up to be a 16. So we have a center. The center of the circle is negative 3, 2. It's the opposite of the 3. So we put a negative 3 here, we get 0. We put a 2 here, we get a 0. And r squared is equal to 16. So the square root of r squared is plus or minus the square root of 16. So r is equal to plus or minus 4. But the radius has to be positive on the circle. So we have a center of negative 3, 4. We have a center of x is negative 3, negative 3, 2. I don't know why I said 4 then. Negative, x is negative 3, y is 2, right there. And I'm going to have, I've already marked off the radius for 4 units. So let's see, mark out 4 units from the center. So if I go from here to right there, that's 4 units. So I put my compass at the center because the compass draws a circle. Here we go. Whoop. Better keep that down. So here we go. And again, this is an approximate. This is the circle. And I'm drawing the circle. As you can see, I'm drawing the circle heavier. But the center is negative 3, 2. The radius is 4. Another way you could do it is plot the, make that a negative 3, 2. Again, I don't know why I call them the 4. Go 4 to the right, 4 to the left, 4 down, and 4 up. And when you draw your circle, again, you do it freehand, but the boundary line is no equal sign. So the boundary line is broken because it says less than 16. Less than, the boundary line didn't say equal to, so the boundary line is not solid, it's broken. And less than should be inside. So we're shading on the inside. Greater than, so all the points inside of this circle make this inequality true. And again, to test that, let's use a test point, and it didn't pass through 0, 0, so let's use 0, 0 as a test point. So x squared plus y squared plus 6x minus 4y less than 3. X is 0, y is 0, x is 0, y is 0, 0 plus 0 plus 0 minus 0 less than 3. So 0 is less than 3 and 0 is less than 3. That's true. So this test point here satisfies the inequality. So again, that tells us that we're shading on the inside. So the solution is the shaded area. So you can write down the solution is the shaded area. All points that lie on the inside of this circle satisfy this inequality. So the solution, if you want to write it down, the solution is the shaded region. And I could have did that for the last one. The solution would be the shaded region and the boundary line for the parabola. So that brings us to the end of the video and brings us to the end of the extra problems that we done on inequalities. And if you like my video, click the like button, click the subscribe button if you want to subscribe to my channel. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.